All right, let's dive in. We're talking about a technological shift that's happening as we speak, a powerful convergence that is literally rewriting the rules of our physical and digital worlds. It's all about the fusion of three incredible technologies: digital twins, artificial intelligence, and extended reality.
So, let me start by asking you a question. What if you could build a perfect virtual copy of anything, a jet engine, an entire city, maybe even a person, and then use that copy to test out every possible future? Well, that's not science fiction anymore. That is the core promise of what we're going to unpack today.
So here's our game plan. We're going to start by breaking down the three key technologies. Then we'll look at how they're already changing everything. After that, we'll get real about the huge challenges they face. And finally, we'll peek into what's just around the corner.
Okay, to really get a handle on this, it helps to think of this whole revolution as being built on three main pillars. Just remember these three words: the foundation, the brain, and the interface. It's a simple way to see how all the pieces fit together. So let's look at how this whole thing is built. It all starts with the digital twin. That's our foundation, the virtual blueprint. Then we layer on the AI. That's the brain, the part that does all the thinking and makes sense of the data. And finally, you've got extended reality, or XR. That's our interface. It's the immersive window that lets us actually step inside and interact with it all. You see? Each layer builds right on top of the last one.
So what in the world is a digital twin? Well, think of it as a perfect virtual copy of something real, say a wind turbine out in the ocean. But here's the magic trick. It's not a static 3D model. It's a living model, constantly being updated with real-time data from sensors on the actual turbine. That means the virtual twin is an exact mirror of its physical counterpart, second by second. Now, having that perfect mirror is great, but AI is what gives it a spark of life. This is the brain, the cognitive layer. The AI takes that nonstop flood of data from the digital twin, and it starts to see patterns, to predict what's going to happen next. It turns the twin from just a passive reflection into a proactive system that can actually learn and get better. And this brings us to the final piece of the puzzle: XR, or extended reality. This covers everything from virtual reality to augmented reality. You can think of XR as the bridge, the thing that lets us humans actually step inside all this data. Instead of staring at boring charts, we can put on a headset and literally walk around a virtual factory floor, seeing real-time data pop up right on top of the machines. It makes all that complexity totally intuitive. And let's be really clear, this isn't just some cool academic project. This is becoming a massive industry. The market for digital twin tech alone is projected to explode to over $259 billion by 2032. That's a huge wave of investment, and it tells you that major industries are betting big on this becoming a core part of how they operate. So now that we get the three pillars, let's look at what happens when you put them all together in the real world. Let's see how this convergence is already creating some pretty incredible results. Let's start with smart manufacturing. Now, this table might look a bit complex, but don't worry about the algorithm names. The only thing you need to pay attention to is that performance column. Think of that number as a score out of 100 for how well the AI can predict the future. For predicting the quality of a part coming off the line, it's over 94% accurate. And for predicting energy use, it's almost perfect. That means factories can massively improve quality while also becoming way more sustainable. But maybe the most mind-blowing application is in healthcare, with this idea of a human digital twin. And this quote just nails it. It's not just about predicting if someone might get sick. It's about building a virtual model of you to understand why, to see the actual biological machinery inside that's driving a disease. The promise here is just staggering. I mean, we're talking about creating a personalized model for something as complex as heart failure. We could identify unique groups of patients to give them hyper-targeted treatments, or even run virtual clinical trials to see how a digital version of you would react to a new drug long before you ever take it. This really is the future of personalized medicine. And it doesn't stop at things we can touch. This tech is being used to build digital twins of entire cities. XR basically becomes this magic lens that lets city planners see all the invisible systems that make a city tick, visualizing traffic flow, energy use, even how people move around, all in real time to design smarter and more livable places for all of us. Okay, this all sounds pretty incredible, but Building this kind of virtual future is obviously not going to be a walk in the park. There are some really significant technical and, more importantly, ethical hurdles that we absolutely have to figure out. Let's dig into the biggest ones. First up is basically a physics problem: latency. You can just think of it as lag. If the digital twin for a self-driving car needs to make a split-second decision, it can't afford to send data halfway across the country to a cloud server and wait for an answer. That tiny delay could be the difference between safety and disaster. The answer is something called edge computing, where all the thinking happens right there, on the car, allowing for that instant, real-time response that is absolutely essential. Another massive headache is just getting all the data to speak the same language. Right now, information from the factory floor, from the IT department, from medical records, it's all in different formats, stuck in these separate silos. To build one big, cohesive digital twin, you need really complex translators. And just to make things more complicated, different groups are developing their own competing standards, their own technical languages. It just adds another layer of difficulty to making everything play nicely together. And that brings us to the most critical challenge of all: the ethics, especially when we're talking about human digital twins. I mean, here's the thing. Even when we think data is, quote, anonymized, unique patterns can sometimes be used to trace it right back to a specific person. Then there's bias. If the AI model is trained on data that isn't diverse, its predictions might be unfair or inaccurate for certain groups. And how do you give consent for a digital copy of you that's constantly changing and learning? The absolute bedrock here is public trust. If we lose that, this whole thing fails. So yes, the challenges are very real, but the momentum behind this is just undeniable. So where's this all headed? Let's look a little further down the road. The next huge wave is going to be generative AI. See, right now, building one of these detailed 3D models is super expensive and takes forever, but generative AI is poised to automate a ton of that work. Just imagine being able to describe the factory you want to model and an AI just builds it for you. This is going to be a massive accelerator, making this technology accessible to way more people. So for any company or developer trying to figure out how to navigate this future, a pretty clear path is starting to emerge. It starts with building everything on an edge computing architecture for that real-time speed. Then it's about breaking down those data silos. You need specialized AI that really understands its specific job. But, and this is the most important part, you have to build in strong, proactive ethical rules from day one. And finally, the big goal is to use tools like XR and generative AI to get this power into everyone's hands. So we'll end on this thought. As our ability to simulate reality gets better and better, as these virtual copies become more and more perfect, we're forced to ask a pretty deep question. When a virtual model can predict, optimize, and interact with the physical world this flawlessly, what does it even mean to be real anymore? That's a question we're all going to be answering together.